And here we go with lesson number 4, and this one's all about functions. So we've done a little bit of work with functions before, hopefully last year, and this is just a funky way to show what you're inputting, what you're using for x, okay? So the x is the input, and the f is the name of the function or the name of the output, okay? So let's just not forget that a function is a relationship where each input corresponds to one output. I like to associate this with cell phones. When you dial up a number, you're expecting to get one person, okay? It's not going to be a random call where you might get somebody else. It's a direct relationship, a one-to-one. Now, a cell phone could call the same person, but on a different phone number. So let's say they have either 2 cell phones, or they have a work phone number and a cell phone number, and you could choose which one to call. Still functioning, because the input that you're getting is giving you the person that you want, okay? And we'll talk more about what it means not to function and to function. But right now, we're just talking about the notation for how you would figure out the value of the output given the input. So we're typically used to seeing equations written like this: y equals 2x plus 3. What we're going to do is add in f of x. Now, f of x or g of x or whatever letter they're using is just helping you represent the output, okay? It's telling you the input they're using and the output that you would get. Now, it's important to know that in this particular example, whatever this x value is here, it will show up again over here. Again, that's what the input is. All right, enough talking. Let's get to it and see what we have to do. So let's evaluate the following functions using substitution or a table of values on your calculator. When it's just one number, it's probably easy enough just to substitute. So what we do is we take a look at the function. This is f of x equaling 4x minus 7, and we want to find f parentheses 3. So all that means is that the x value is 3, okay? So we go back over here, and wherever we see x, we simply substitute in 3. So this tells us the input, and now it's here where x was. And then after that, it's just simple math. So a little bit of order of operations. We're going to multiply before we subtract. 4 times 3 is 12, and 12 minus 7 is 5. So the output is 5 when the input was 3. Okay? Now, this is also important to realize that this is simply a point, an x and a y value, where the 3 was the x value and 5 is the y value. So I mean, like one of those things you would put on a graph. Since you can put it on a graph, we can come up with a table of values. Okay? So let's think about what we did with the graphing calculator. I want to find the input of 3. So let's go to our calculator. I'm going to start kind of like what your screen would look like. And so if I was on a blank screen with the calculator on, all I would do is press y equals, and then I want to put in the expression 4x minus 7. 4x minus 7. And if you weren't here for a graphing calculator video, please go back and rewatch that and get yourself up to speed, and hopefully this will serve as a bit of a refresher. Now, instead of doing the whole math part of this, we just hit second graph, which brings up our table, and we want to find the x value of 3, which is sitting right down here on my screen. If you have to scroll down for it, please go ahead and do so that you can see what you need to. So the output is 5, just like what we saw when we substituted 3 in. So you can find it in a table, or you can do the math. It is really up to you. Let's do one that's a little bit more challenging. And this one's g of x. They can change the letter to whatever they want. It just sometimes is related to the situation. There is a bit of a typo over here. This should be g as well. So g of x is equal x squared minus 3x plus 1. And we want to find g at negative 2, which means the x value is negative 2. So I'm going to go back and put in negative 2 wherever I see x. Now this one has an exponent, so be careful. I need to put parentheses around what I'm substituting. So negative 2 in parentheses, minus 3 times negative 2. Again, wherever there is an x, I'm using negative 2 for this particular problem. And after that, it's order of operations again. So please excuse my DRAM Sally or PEMDAS. We start with parentheses first. And we don't really have any parentheses in which there's an operation inside of them. But what we do have is parentheses and an exponent. So I want to do that exponent first. So negative 2 to the second power is negative 2 times negative 2. A negative times a negative is a positive 4. And then I'd want to rewrite the rest of the problem. After this, it's very tempting to maybe subtract 4 minus 3, but I really want to multiply first. So I'm going to do negative 3 times negative 2 for a positive 6 plus 1. And then it's just 4 plus 6 plus 1, which would end up being 11. So we can write this out as g of negative 2 equaling 11. Now some of you were saying, why didn't you write it the whole time? I could have, no big deal. It's something that we don't really need to write. It is important to understand that this is an x value and this is a y value. This is the input that gave us this output. And we can also see this as a point, negative 2, comma 11. Okay? We can also do this in the calculator. So let me show you how to do that real quick, because this is going to be important. So, go to the calculator, and let's clear out what we have. Let's go to y equals, get rid of that old linear equation, and you're going to tell me that this is a quadratic, right? Because it's raised to the second power, and it was just on the tip of your tongue. So x to the second power minus 3, whoops, and I cleared it. I'll use x to the second power minus 3, x, and then adding 1. Okay? And all we have to do is press seconds and graph, brings up the table. We are looking for an input of negative 2, and there it is. Negative 2 and 11, just like we saw when we did it with paper and pencil. Okay? Hopefully you're finding the graphic calculator to be very useful. Next up is kx. Again, they can change the output letter as much as they want. It's the same process. We want to find the square root of x minus 7, and we want to find, and again, another typo here, apologies, it should be k at 4. So we change this to k. So that means we're going to replace x with 4. So now we go back, and wherever we saw on x, we put in 4. And that's just what we normally would do. We evaluate the expression. The square root of 4, 2, right? Square root of 4 is 2 because 2 times 2 gave us 4. And then minus 7, and 2 minus 7 would be negative 5. We would have to subtract those because they're different signs, this being positive. Again, I can write this at the end, and this helps me see the x value of 4 with a y value of negative 5, a point on a graph. Okay? Next up, I want to make that x and y table, the table of values. I want to find 4. I can see that I didn't update the table over here. So negative 2, 11. I could have wrote some other ones down. Alright, so let's review how we find the square root key. I'm hoping you're finding this class kind of spiraling. Meaning you've already done something and we're using it again. That's the whole point. I want you to be able to feel like you're using something that you've already learned. Alright, y equals, clear out the quadratic, in comes the square root. Who remembers what the square root looks like? Maybe from that left side page. Yeah, that kind of arching R, right? That really long R with the line up at the top. So let's go y equals. And how do you find the square root button? It's right above the x squared, because it's the opposite of that. When you double something, or not, excuse me, double something, but if you use the same number twice and multiply, it's the opposite of doing the square root. So this was the square root of x, and I got to get out, so follow that blinker, and get to the right using the right arrow key, and subtract 7. And then go seconds, graph, and we want to find the table value of 4. So it's not on my screen, so I'm going to scroll on down, and there it is. It is an integer. That's awesome. It is 4, negative 5. And look at that R. Yeah, there it is. That long, extended square root function. Okay? Quickly, back to the notes. And like we said, it's going to be the same as if you did it by hand, or if you did it with a graphic calculator. So your choice right now. Alright, next page. And this is just kind of all about what a function is. And a function, unfortunately, has a lot of vocab, but if we get the hang of it, it's not so bad. So the domain values are inputs. So domain, input, or x. They all kind of mean the same thing. That goes in, and then the function produces an output or a range or a y value. So this is kind of like the phone number, the input, and then this is the person that you're trying to reach. Okay? Now, let's take a look at these in terms of an ordered pair. They need to be given to us as a point, an ordered pair, an x and a y. And we saw that from our table. We can do this as a mapping, where this number gives me this, 3 gives me -1, 4 gives me -1, 4 gives me 3. We can do it as a table of values. We can also do it from a graph. Okay? How do you tell if it's a function or not? Well, whenever there's the same input, the same x value, with a different output, this is not a function. Okay? And whenever it's mapped from one input with two different outputs, that's a problem. Okay? So this is not a function, because one phone number could call two different people, completely two different people. That's bad. When we see it in a table, again, it's kind of similar to the ordered pairs. I have the same input giving me a different output, not a function. And lastly, the vertical line test. So if you were to draw a line down, and a straight one, it's kind of not very straight, but anyways, a vertical line down, we call it the vertical line test for obvious reasons. And if it hits twice, there's 1 point, there's a second point, and it's not a function. It's not functioning. All right? It's not working. And so that's important to remember for that. So whenever we're asked to write the domain and range, we're asked to write the x values and the y values. So the domain is always the x values, and they're written in these funny fish lip brackets. So these are just simply -3, 3, and 4. And I don't have to write the x value more than once if it's listed twice. And then as for the range, I'm just going to make a list of y values, and I would like to put them in numerical order, -1, 3, and 4. Okay? And so those are the x values and the y values, the domain, the range, inputs, outputs. Okay? They all kind of mean the same thing. Alright, last page, we're done. So let's take a look at this function, f of x equaling 2x plus 3, and just answer the following questions. Hopefully this goes really fast after everything we've done so far. Find the value of f3. Remember, always going to be labeled as x value. So that means 3 going in for x. So wherever I see x, I replace it with 3. And so this should be pretty simple. 2 times 3 is 6. 6 plus 3 makes 9. So I've just made the point 3, 9, or an x value of 3 and a y value of 9. Another question, but it's very similar. What is the output or input of -5? So input x, and that means we're going to do f of -5 equaling 2, not x anymore, but -5 plus 3. So they've just changed the input. We're just going to call somebody else. Sometimes you're going to see these written horizontally. I want to show you that. I'm not trying to confuse you. Just show you another way how this would be done, where we would multiply first here, get -10, add the 3, and end up with an output of -7, or a y value. Okay? What if the domain is 2, 4, 6, 8? What would be the range? Domain is x, range is y. Still to this day, I remember this because it's alphabetical order. D before R, x before y, and alphabet. So for this one, it would be best to go to the graphing calculator. So we would simply want to type this into the y equals, clear out whatever space jump you have, and insert the expression to x plus 3, and then go to second graph, and you would find the values you want. You want 2, 4, 6, and 8. So we want the 7, the 11, 15, and I didn't get the 8 because I didn't go far enough down. So let me go down a little bit, and you would do just like one more. And all my values are still in the same spot. So what is the range? We want to put this in official brackets and say that it's 7, 11, 15, and 19. So I'm running a little bit low on time. I'm going to show the answers. Please let me know if you have any questions. All right, so there's the answers. Hopefully from my annotations, and from what we've done in class, that makes sense. But if not, please let me know if you have any questions, and we'll see you on